Example 4. Since November 2007, the average time it takes fast trains to travel between London and Paris is 2 hours and 15 minutes, with a standard deviation of 4 minutes. Assume a normal distribution. What is the probability that a randomly chosen trip will take longer than 2 hours and 20 minutes or less than 2 hours and 10 minutes? Go ahead and pause the video now. All right, so we'll start by defining our variable x to be the time taken to travel in minutes. And we know that x is normally distributed with a mean of 135 and a variance of 4 squared, or a standard deviation of 4. We're asked to find the probability that x is greater than 140, since we've converted all our time to the measurement of minutes. We'll go into our graphing calculator. Okay, and again, we're going to press second vars to get to our distribution menu. Select option 2, normal CDF. Here, our lower bound is 140, and for our upper bound, we want to set a really, really large number because the graphing calculator cannot accept infinity as an input. And then our mean is going to be 135 with our standard deviation being 4. Press paste, and we get our probability of 0.106 rounded to 3 sig figs. And we can also sketch a curve to see what this looks like. So we know that for all values above 140, exists 10.6% of all the observations. Now we want to figure out the probability that the trip will take less than 130 minutes. So again, go into our calculator, second vars, go into normal CDF. This time we want our lower bound to be negative 1 times 10 to the power of 99, or just some really large negative number. And our upper bound is 130. Our mean and standard deviation are unchanged. And oops, I think I've entered something wrong here. So let's go back to our distribution, probably because I put 1 times 11. So let's change that to 10. Okay, trying that again, and guess what? We get the exact same value, telling us that these two values are exactly the same distance away from the mean. Example 5. The time taken by students to complete a puzzle is normally distributed with a mean of 28.3 minutes and a standard deviation of 3.6 minutes. Calculate the probability that a randomly selected student took less than 30 minutes to complete the puzzle, and B, that out of 10 randomly selected students, at most half of them took at least 30 minutes to complete the puzzle. Now, this is a more challenging question that involves both the normal distribution, which is a continuous distribution, as well as the binomial distribution. So that's your hint. Please pause the video and spend some time trying to work it out. Okay, let's take a look at the answers together. So we will start by defining our random variable x to be the time taken to complete the puzzle. Now this is very important that we take the time to define our variable, because as you can see in the solutions, our distribution ends up changing. So we need to introduce a new variable. Let's see what we mean by that. All right, so we know that x from part 1 is normally distributed with a mean of 28.3 and a standard deviation of 3.6, written as a variance of 3.6 squared. Here's a sketch of what our distribution looks like. We want to figure out the probability that a randomly selected student took less than 30 minutes to complete, took at least 30 minutes to complete the puzzle. That means 30 or more. So we're looking everything to the right of 30. And the probability can be found by going into, again, our distribution menu. We always select normal CDF. Our lower bound is going to be 30 this time, and our upper bound is going to be some large number, which we will make 1 times 10 to the power of 99, 8.3, and our standard deviation is 3.6. So we paste that in. and we obtain a value of 0.318, or 31.8%. Now, part B. Out of 10 randomly selected students, at most half of them took at least 30 minutes to complete the puzzle. This is indicative that we need to switch to a binomial distribution. Remember the qualities of a binomial distribution. We have a fixed number of trials, and there's either success or failure. Okay, so 2 possible outcomes. Each trial is independent of the others. We have to define a new variable, so we're going to use y this time. And we'll let y be the number of students that took longer than 30 minutes. We know the probability of success is 31.8%, so p is 0.318. The number of trials is fixed at 10. And we want to know the probability that y is less than or equal to 5. Since the question is asking, at most half of them took at least 30 minutes. So the at least 30 minutes was taken care of by the way that we defined our random variable. So now we're going to go into our distribution menu. We're going to scroll up this time and look for our binomial CDF, since we have a less than or equal to function. Number of trials is fixed at 10. Our probability of success we found to be 0.318 from part A, and we're looking for when x is less than or equal to 5. So we paste that value in, and we get a probability of 0.938 rounded to 3 sig figs. Okay, folks, please take some time and work through the Cognigy questions. If they're not yet available, my suggestion is to go into your Cognigy textbook and look at all the unfinished assignments and go through that. If you have managed to complete all the assignments, which based on my current knowledge is not as likely, then I would suggest going in and looking at the next lesson. You can preview next lesson, which is also normal distribution, but this time we're going to be looking at the inverse normal as well as the standard normal distribution. That's it for today. See you next class.